Good morning. We're going to start the dissection. As I was telling you before, this is the whole brain. This brain is a little bit atrophic. Nonetheless, it's more useful because the sulci are better defined. Let's start by the parts of the brain that can be seen in this view. So we are looking at the basal part of the brain. So the position of the brain will be, obviously, this one will be upside down. And we look at lateral view. You can see the brain stem just going down. And then just we're going to center into the parts that can be seen in this basal view of the brain. To start, you will have to remove, as I was saying, all the vasculature and the big vessels that can be seen, like the polygon of Willis. And then just all that should be removed. And to start with, we could see here both vertebral arteries. These vertebral arteries will join in the basilar artery in the center, the thing that I take with my forceps. And then after giving up some branches, like the most important one is the anterior superior cerebellar artery. Then the basilar artery splits into two branches, which are respectively one and the other posterior cerebral arteries. Can we put some zoom in the center? If we zoom this part of the brain, yeah, we'll see more closely. Yes, so one vertebral artery, the other vertebral artery, basilar artery, there will be the posterior cerebral arteries. Then we can see also different brainstem cranial nerves. This is just something that is going there. And so we can expose a little bit more the center of the area. Then we can see underneath the posterior cerebral artery, we can see the cerebral peduncles. Notice also this white band. This is atheroma plaque, so atherosclerotic deposit of lipids in the wall of the artery, which is obviously reducing the flow of blood, and that's something that is seldom taken into account when we are looking or we are exposing one brain diagnosed, for instance, for Alzheimer's disease. There is very often a vascular component. The other big system that the vascular system that we can see in the brain is the carotid artery. This is the carotid artery. Also is full of plaques, arteriosclerotic plaques. So we can understand that the circulation, the blood flow in this case wasn't perfect, but nonetheless will be it's sufficient to maintain the basic activities of the life. Then the carotid artery then divides into the anterior, and we can see here, the anterior cerebral artery, and then this anterior cerebral artery communicates with the other that will be underneath the pia, so we'll be seeing. And then they will go the course of this anterior cerebral artery through that will be in the surface of the medial side of the hemisphere. Well, the middle cerebral artery goes, like you see here, to the lateral fissure. Continue. So I was saying that the cerebral artery, the carotid artery, that gives the main branch, which is the middle cerebral artery, and then the other branch is up here. That will be the anterior cerebral artery. This is the anterior communicating artery, and then both anterior cerebral arteries will go in there. So all that needs to be removed, and that's what we're going to do right now. We just take away all this material, those vessels. Don't worry about too much about the pia of the brain stem, because we won't be using it. And then we go to this part. In this case, in this particular case, I didn't see the communicating arteries that will be between the carotids and the vertebrovascular system. So it's possible that they are really thin and I didn't see it, or perhaps they can be independent. So the variability in the pattern of the circle of Willis is very high. So that's something to be taken into account. We can see here, just to show, because it's a curiosity, the 8th cranial nerve, right here, relatively big, is just exiting the brainstem in the angle between the medulla and the pons. We continue the cleaning all this material. You may have noticed that the surface of the brain is atrophic, so the sulci are really well marked. That's an advantage, just to show more clearly what is the morphology of the sulci. That's something that we have to work. We're removing now the pia on the lateral surface. Just we follow the course of the middle cerebral artery. We can take all the distance. You can see how far away it goes through the temporal lobe, just the insular cortex between the insula and the temporal lobe, and then you can peel off all these structures here. What is important is just to have as clear as possible where is the main sulci of the brain. So you can talk more precisely how far back goes the frontal lobe in relation to the parietal lobe or the occipital lobe or the temporal. So that's everything that is needed in order to get. Thank you. The hemisphere clean. This can take, recommended to do it carefully, not to damage the surface of the brain. In this particular case, it's very easy. Perhaps in your specimens won't be that easy, but we'll be looking around. Not everything goes well. Well, without being exhaustive in this way, it is pretty much clean the major part of the pia matter. Now we look at the clean surface of the brain, and then we should identify the main sulci, which is favored obviously by the atrophy of this part. Globally, you can see, for instance, as a measure of the atrophy, just the insular cortex in the bottom of the lateral sulcus. So just beginning by the temporal lobe, we'll go all the way as far back as the junction with the parietal and the occipital lobes. Then the lateral fissure is obviously the easiest one. Then we have to identify the central sulcus. And the central sulcus is this one here. I'm following the floor. It goes all the way down to here. And then we can identify the precentral gyrus. So the premotor area will be in front of this gyrus. The gyrus will correspond to the primary cortex, so that's also interesting to notice. The postcentral gyrus will be the somatosensory part, although in the bottom, close to the temporal lobe, and will turn into more just integrative functions in terms of spatial information and so on, that you know better than what I do. Then, once we're identified, so we can see all this is the size, all that is frontal lobe. So we are frontal people, in essence. So that will be the parietal lobe. So we can find here the intraparietal sulcus will be here, and then we'll find the superior parietal lobule and the inferior parietal lobule, which is in that sense the highest hierarchy in the processing, for instance, for language, the Wernicke area that will be around there. And there is no clear separation between the parietal and the occipital. But nonetheless, in the middle part, we can see the parieto-occipital fissure. We'll see there. And when we separate the brain, we'll be looking at more closely. So we know that this rear part corresponds to V1, and then will be progressively V2, V3, V4, and so on. So this is the occipital plus the parietal lobes in that sense. And the temporal lobe is marked, as we saw before, by the lateral fissure. And then we can see the superior temporal sulcus is really big, is really atrophic, so we can see it more clearly than anything else. And then it continues at the rear part. And then we can have here the different gyri of the really important areas, like the angular gyrus or the supramarginal gyrus right there. Then we have the inferior temporal gyrus, and then it's separated by the inferior temporal sulcus. And then we are going to the part that we are most interested, the basal part of the brain. And in the basal part of the brain, we can see the superior, the middle, the inferior temporal sulcus, and then we move to this other gyrus. It's a little bit of out of thing. This other gyrus, that will be the fusiform gyrus. We look at it more in detail when we remove the brainstem, because you can see that other than the tentorium, the dura mater sheet that separates the cerebellum from the inferior surface of the cortex. So in just a series of coronal sections, when you get just the brain stem, you are relatively still rostral in the remainder of the brain. That's one of the purposes of the course in terms of having a clear picture. How is the relationship, the relative relationship of different structures? So finally, we reach the parahippocampal gyrus, which is here. So that will be the entorhinal cortex, extremely atrophic, and then you can see the uncus. And that's something that you don't see in the regular brain, because it's hidden by different elements, and mainly because the temporal lobe is bigger and occludes the view of the uncus. So we can take a closer view on this side. That would be right there. What is the focus? We need to focus a little bit more. Yeah, that will be the end of the uncus. So we are looking now at the gyrus intralimbicus. No? That will be exposing that. That's as far as the general topography of the brain. Let's go to the brain stem a little bit more. And then we find the cerebral peduncles right here. Those are to be sectioned later on, one and the other. This is the interpeduncular fossa. It is not very clear, the illumination. Yes. But nonetheless, it can be seen, you will recognize in your brains very, very quickly. And then these two prominences here are the mammillary bodies. So those are extremely clear. So where is the limit? So the cerebral peduncles belong to the mesencephalon. So we are looking at the ventral part of the mesencephalon. We shouldn't forget that, because if we turn around the brain, and we pull the cerebellum down, then probably they can be seen at the bottom, both superior and inferior colliculi. And then that's the boundary with the boundary with the diencephalon. So we'll be sectioning the cerebral peduncles to separate the whole brain stem from the remainder of the brain, beginning in the diencephalon. Immediately behind and separated by a sulcus is the pontopeduncular sulcus. We find the surface, the big surface of the pons. It's crossed by fibers, so you can see perfectly the outline of the transversal fibers. Those are connections between one part and the other of the cerebellum. And then we have here the boundary with the medulla. That will be the pontobulbar, it's the pontomedular sulcus, and then it's the origin of different brainstem cranial nerves. Then we follow here the medulla, and that's the anterior sulcus. And we have here, I think they can be seen, at least in this side. Let me just move towards the center. There. A little bit of zoom. That's the inferior olive. So it's not very big, it's a little bit atrophic, but nonetheless it can be recognized with easily. Yeah, so we have the three main parts, mesencephalon, pons, and medulla. And then, this is in the autopsy, it's cut the upper part of the first segments of the cervical cord. So that will be the end, that will be the spinal cord. So once we have this ready, we can work on the ventral part of the diencephalon. This is the pia around the optic nerves. It's extremely hard to take it away. Okay. So, well, in the basal part of the brain itself, we can see the olfactory structures. Will be the olfactory bulb. And here it's a little bit hidden by gyrus rectus, which is in the orbitofrontal cortex. Then the olfactory stria, and then the division, it cannot be seen too clearly, but I will remove a little bit of the pia. Okay, now it can be seen better in this view. Yeah, the division on the medial and lateral olfactory stria, which is quite interesting in that way. The lateral one will go to piriform, periamygdaloid, and also a portion of the entorhinal cortex. And that's all the central projections, direct central projections from the olfactory bulb. Then we have what there will be the first cranial nerve. We have here the second cranial nerve. And we can see very easily that the optic chiasm. That's where both optic nerves fuse together, cross fibers, and then continues with the optic tract that can be seen also as a white strip in the ventral part of the brain. This is the pituitary stalk. Then we don't have the pituitary gland. It remains in the basal part of the cranium, and then this little slit covered by a small membrane That's the opening of the third ventricle. We'll be using that as a guide in order to bisect the brain. So we have here the anterior hypothalamus, rostral to the pituitary stalk, and then will be like the anterior preoptic area and so on, really important structures in the vegetative life. And then we have the middle, is indicated by the pituitary stalk, and then we have the posterior part of the posterior hypothalamus that will end in the mammillary bodies. So we'll have to meet together the part of the brainstem and the part of the diencephalon. We can follow this optic tract laterally because if we are lucky, we could be able to see the lateral geniculate nucleus at the bottom that is a bit atrophic. They are a bit atrophic and they cannot be seen clearly. So usually they are identified just by histological sectioning. So we now can go towards the removal of the brainstem by cutting the cerebral peduncles. So we take the knife. And then we have to look at both sides. In this view, we can see that this is through the inferior colliculus. That will be the superior colliculi. And then the remainder of the ventral part. In this case, you can see the substantia nigra in there. And, well, in here, it can be seen the red nucleus as well. So this is the first part of the dissection. And now we will be able to look at the basal part of the brain. One side has been a little bit deeper than the other side. It can be compensated, nonetheless. And we can continue the section. You have to be careful with the little things that remain, because sometimes they are not easy to remove. But we have here a better glimpse of everything. So once it is liberated, the brainstem, then we go to the middle part. It's just to follow the middle line. So by now, the hemispheres can be separated rather easily. And then we go to section, perhaps by scissors. That depends on how the morphology is and so on. Just to go. And we section. And then after that, we can continue with the scalpel, going through the middle of the mammillary bodies. One is not exactly on the midline, but we'll try to make it as close as possible. Yeah. Okay. And we cut what we see here in the middle. That's something that can be seen only once, a little bit more of focus. This is the interthalamic mass. So we have to get rid of that. Carefully. One side and the other. Let me remove the extra tissue here. There's nothing. And it's occluding the view of both fornices. You can see here. This is the anterior commissure, and here is the anterior pillars of the fornix. They are now descending towards the mammillary bodies, and then they come in from behind, and then they hang on the corpus callosum. We are going to clean now is the choroid plexus of the third ventricle, which are basically vessels, as you can see. The posterior choroidal arteries, right here. We remove that. And then this part of here. I will save in this side because before removing that, because this is the irrigation of the hippocampus in a great extent. It will be the anterior choroidal artery that we need to remove. That's a part of the posterior, is a branch of the posterior cerebral artery. Well, those are the important structures. I think you can see, perhaps we can, un poco de papel. Then at the back, Marimar has just sectioned the pineal gland. I'm going to dry a little bit so it can be seen better, because that will be the hippocampal commissure. And that's the fornix coming from the hippocampus, the back of the hippocampus. Here will be, and later on will be shown by Marimar, the tail of the hippocampus. Then it continues right here and forms the fornix, which is underneath the corpus callosum. Then it makes a turn behind. That will be the post-commissural part of the fornix, behind the anterior commissure. A little bit, another part will go to the septal nuclei that will be in that region. So once you have all that open, you have the possibility of sectioning with a cerebrotome. This part will be the rostrum of the corpus callosum that will be splitting. We're going to try to do that as carefully as possible, just to maintain both fornices separated. Once it is cut, we go to the rear part of the corpus callosum, which is the splenium. That is the thing that I'm cutting right now, the splenium of the corpus callosum, and it comes open by itself. That will be the cavity of the lateral ventricle, and then we have to, or we can extend towards the rostral part. That's because I prefer to do it with a scalpel, but nonetheless it can be done equally well with the cerebrum. And we have both halves of the brain, and yeah, we can take any one of those, and we peel off the branches of the anterior cerebral artery, and then we can identify the complete identification of the lobules and sulci of the medial side of the hemisphere. And you see how clear is now, it comes spontaneously, the parieto-occipital fissure that will join here. That will be the calcarine sulcus. Then, although it's somewhat interrupted, but they will join together here. And yes, it's one of the landmarks that I consider interesting. I'm removing now the choroid plexus inside the ventricle, part of the third ventricle, fourth ventricle is in the brainstem, the lateral ventricle in the frontal and occipital horns. So we have now rather free all the structures in the medial temporal lobe. I guess you can see better right now what is the extent of the uncus. A little bit of zoom, because we won't be, yeah, perfect. So we're going to start. This is an atrophic brain. This is not a normal brain. This is an atrophic brain. You have to take into consideration that in our program of brain donations, come people from every age and every condition, and some of them have problems, cognitive problems. So I'm sure that in this case it could be something like, the frontal part looks very, very atrophic. So I guess that perhaps it could be a frontotemporal dementia. Anyway, we have here the collateral sulcus. This is an opening, really unusual, but you can see that here is the parahippocampal gyrus. There will be the fusiform gyrus, and then we'll go to the lateral occipitotemporal gyrus, the inferior, middle, and the superior temporal gyrus, as we were saying before. So that's the order, and in every cross-section, it's interesting to try to identify these 5 things. Anyway, here, the temporal pole, really atrophic. A big dimple, that's the rhinal sulcus. That's the real rhinal sulcus. And then you can see that it's almost perpendicular to the direction of the collateral sulcus. The medial side, and I don't know whether it can be seen, the fimbria. Here, like a white, yeah, I think that's a better situation. That white strip, and then it comes around. It comes around behind the thalamus. There will be the pulvinar of the thalamus, and then joins the fornix. Well, joins the hippocampal commissure right here, and then the fornix. And in the medial side, what is not the temporal lobe, we can see the whole part of the thalamus, hypothalamus and thalamus. But continuing with the medial part of the temporal lobe, the hippocampal fissure is open, and also is the choroidal fissure. But let's look just at the other bumps, and to turn around, and then we have here, we identified before the rhinal sulcus, and then we have here this little sulcus. We need a bit of zoom in there. Because it's hidden in that part. That will be the sulcus semiannularis. I see that it's difficult to see. So that will be the sulcus semiannularis. Then, so this will be the dorsal part of the amygdala. And then we have here the gyrus ambiens. This little dimple will be the intrarhinal sulcus. So we have gyrus ambiens. That will be the beginning of the gyrus uncinatus, and then the continuation, and we can see perfectly the gyrus uncinatus, the band of Giacomini, so that little prominence in the middle, right there, and then the gyrus intralimbicus, just to end the uncus. I think these parts can be seen clearly, which is not very often the case, but nonetheless, you can examine this brain very at your ease. Well, another identification now, because we have seen the uncus, we have seen the fimbria going around and joining the hippocampal commissure behind, better in front of the splenium of the corpus callosum. Then what else can we see? Well, we have the piece here. I was showing you. That's the thalamus. That's the tinea of the thalamus. And we have the hippocampus ending. Well, that's something we need to show. But you can see how the anterior pillar of the fornix goes down. It cannot be seen. But if we strip off this part of the medial side of the, I won't do that because it's part of the afternoon dissection, but this specimen is I think is very, very nice. And we'll see going to the mammillary bodies. The important thing that I wanted to remark is the presence of the interthalamic mass in there. And you can see that the most, well, in other words, the posterior hypothalamus is at the level of the, in a cross-section, coronal section, is at the level of the beginning of the thalamus. So the thalamus, with all its size, is dorsal and caudal to the hypothalamus. This is a relationship that is not often remarked, but I think very, very nice and very consistent and very useful in order to try to identify the anterior part of the thalamus. And then we have the rear part of the thalamus, and that's the pulvinar. Enormous size of the pulvinar. You can see it goes around. In fact, the fimbria goes around the posterior part of the pulvinar, and then is where it joins the other part of the fornix, of the other side, and then go just underneath the corpus callosum to end in this anterior part. And these are the main things you have to consider. It's only a couple of details. This part here will be the isthmus, macroscopically, the isthmus of the gyrus parahippocampal, the parahippocampal gyrus, because it narrows here and it corresponds to the end of the parieto-occipital fissure. Something that is interesting that in this particular brain, this occipital part reaches and fuses, as you will see, with the parahippocampal gyrus, the macroscopically parahippocampal gyrus. And well, that completes the dissection.